Okay, hi guys. So we're into chapter 4. We're kind of in the middle of the chapter now, and this is a video that's going to introduce you to a new concept. One of the things you're going to need for the video is definitely a graphing calculator or a scientific calculator, something that has some certain features on it. We're going to be starting to use some new programming features from our calculator: sine, cosine, and tangent. So a scientific calculator should have these. Specifically today we're going to be working on tangent. It looks like tan, T-A-N, but it's pronounced tangent. We're going to be using that feature. So make sure you have a calculator and you know where that button is on your calculator, because we're going to be using it for the video. Alright, so here's what we've been practicing in class. We've been working with triangles, and really specifically we've been working with right triangles. Triangles that form a 90-degree angle in one of the corners. And we have now created this table of memorized, or well, they're not really memorized, but a table we can reference with certain angles in it. Like 11 degrees is one of the angles in our table. And we've pretty much learned that if we know the sides for an 11-degree angle always have this ratio of 1/5. And we have this big table, a chart, that we can go look that up in. You could memorize all these numbers, but to memorize all that would be a lot of work. Probably a lot of unnecessary work. So what we've been using this to do is we've been giving you different types of problems. Like, let's say you had x over 25. X on the side and 25 on the bottom. You can solve for x when you know the ratio. This is called the delta y over delta x ratio, our slope ratio. And so all you would have to do is say, well, it looks like the ratio is x and 25. So x over 25 equals 1/5. Cross multiply, so 5 times x is 5x. 25 times 1 is 25. Divide by 5 on both sides. And 25 divided by 5 is 5. So we got an answer, x equals 5, so this must be 5 units long. And we can do that for anything that's in our trig table, but not everything is in that table. And I guess if I wanted to sit here all day long and make a giant table with every single possible degree of a triangle in it, and I mean, we could eventually do that, but there are some easier things out there. So today in this lesson, what you're going to be doing in the classroom is learning how to figure out for different angles this ratio in a little bit of a simpler fashion. So we're going to learn about something new today, and I'm going to make up a new triangle. So draw a brand new triangle that's a right triangle. And I'm going to put some numbers on this triangle. I'm going to give you all the side lengths. I'm going to tell you that the bottom is measured 5, the side is measured 8. If I use Pythagorean theorem, I can solve, and I've already done that. The hypotenuse is going to be a decimal. It's like 9.4. I'm going to say 9.4, like 34. It's a decimal that kind of goes on forever, but I'm going to leave it at that. And the angles in this triangle measure 58 degrees in this corner and 32 degrees. So our slope angle is the 58-degree angle. So I'm going to go to my table, look for 58 degrees, and then realize it's not even in our table that we have in class. So I'm going to set this up in a different way. I'm going to say, well, okay, I happen to notice that the ratio is 8 over 5. So delta y over delta x equals 8 over 5. And if I divide 8 divided by 5 in my calculator, it's going to be a decimal. It is 1.6. So this triangle has a ratio of 1.6, and it relates to 58 degrees. Okay, well, I want to show you something cool about this calculator. If you've got a graphing calculator or a scientific calculator, you need to double check that your mode is in degree mode, since we're doing everything in degrees. So like on my calculator, I have a little button called mode right here, which I'm going to hit. You might have to go look for your mode button. It might be somewhere else. And you have some choices. What I'm really worried about is this one right here, where it says radians and degrees. I want my calculator to be in degree mode, so I've already highlighted it and hit enter so that it says degree. You don't want radians. We're not dealing with radians yet. We're only doing degrees. So check your mode, make sure your calculator's set up like this, and then if you quit out of here, we'll be ready to start this problem. So remember, this is a 58-degree angle. that's our slope angle. Well, we have this feature on our calculator called the tangent button, and what we can do is we can use this tangent button, which for me it's right here, it says tan. I'm going to hit that, and it'll show up on my screen as tangent, and I can take the tangent of 58 degrees. And what is the tangent of 58 degrees? Well, about 1.6. Some long decimal, 1.6003345, but if you kind of round it, it's basically 1.6. And what was our ratio? It was 1.6. So the tangent button will find our ratio for any angle that we have out there. It's kind of cool, for any right triangle at least. So it's a really helpful feature in our calculator. So I want to write this down, what we just did, so that we have some notes here. What we just did is we just took the tangent of 58 degrees in our calculator. And we found out that it's equal to about 1.6. So maybe I'll do a little squiggly equal. 1.6003. It kept on going past there. Well, this number is really close to being about equal to 8/5, 8 over 5, our trig ratio. So we have a pretty unique relationship with something going on here. Let's test it out with something else that we know though. Remember those 45-degree angle triangles we were doing the other day in class? It's a 90-degree angle with a measurement of 45 degrees and 45 degrees. This is one of those things that's actually in our trig table. I could go look this one up. I know that the delta y over delta x ratio out of my table is 1 over 1, which is 1. So it's a ratio of 1. So like, let's say I told you that I had a side of 8 down here. I kind of already know what the other side is going to be. It's going to also be 8. It has to have this 1 over 1 ratio, so 8 over 8. Check this out. We'll verify it with the calculator. We'll find the tangent of 45 degrees, and we'll see if it's really equal to the 8 over 8. Now 8 divided by 8 is 1, so really we want to just see, is it equal to 1? So grab your calculator and test it out, see if it is. Alright, so we're going to erase this, we're going to do the tangent of 45 degrees and see if it's really equal to 1, and totally is. Okay, so cool, this is a really cool feature. So I'm going to write that down, tangent of 45 degrees equaled 1. Okay, so how could this be helpful to us? It's like, alright, we know what the calculator can do, we can check some answers here. How are we actually going to apply and use this? Well, there's a lot of ways we can use this. So let's do this. Before we do any applications, let's at least write down a note or two about this so we have something to kind of go back and look at. So we're focusing on something called the tangent ratio today. Those are our words. Tangent ratio. And the way the tangent ratio works is we take a line, so I'm going to draw a line, and we build a slope triangle out of it where you take 2 points on the line and connect them to make a triangle, a 90-degree triangle, and this angle, theta, is formed. And we know that if you can find delta y and delta x, that it helps us figure out theta. Now what we're figuring out is that if you can find the tangent using the calculator of that angle, whatever theta is, could be any degrees. It could be 11 degrees, 12 degrees, 25 degrees, 45 degrees. So tangent of theta, whatever it is always going to equal delta y over delta x. That's going to be pretty handy for us when it comes to figuring out these different triangle problems. Not always is the triangle going to be in this order. Sometimes it's going to be like shifted around, so you have to rotate the triangle a little bit. Like, let's say I gave you a bunch of right triangles that are in different orders. Like, here's a right triangle. Or I could do something like this. Here's a right triangle. It doesn't really matter where the 90-degree mark is, as long as you can figure out theta. So you need to know what angle are you looking for. So it could be any of these. I'm going to make it up. And as long as you understand the relationship, if this is the angle, then the ratio is always the number that's across from it and adjacent. Across and adjacent. So the way we can write this is tangent theta. Instead of saying it equals delta y over delta x, You could also say it always equals the opposite leg, whatever's opposite of it. So the opposite leg divided by the adjacent leg. Opposite divided by adjacent. So like for instance, if this is theta in this triangle, opposite would be right here. This is the opposite leg. I'll just put OPP. Adjacent would be over on the side here. This is the adjacent leg. So how about this triangle over in the corner here? I'll move this over. Where's the opposite and the adjacent? Well, if this is the angle, then opposite is going to be right here. And adjacent is right next to it. Adjacent. There we go. So opposite over adjacent leg, it'll work every time. So I'm going to give you a problem to try and show you how this is super helpful. And then you'll do the rest in class. You'll be kind of working out of the book. So let's make up a right triangle and throw an angle inside of it. So here's my right triangle with a 90-degree mark in the corner. And I'm going to say theta's right here. And let's say theta's, how about 55 degrees? Make up a number here, 55 degrees. And I happen to know that this length on top is 10. This is x. Solve for x. Okay, so first thought would be to go look it up in a trig table. That's what we've done the last 3 or 4 days in class. Go look it up in a trig table and you'll find out we don't have 55 degrees in our table. We probably could eventually find a table that has it, but we don't have it nearby. So I'm going to try and use tangent instead. I'm going to say, okay, I'm going to find tangent of theta, and it's going to equal the opposite leg over the adjacent leg. In this case, theta is 55 degrees. So I'm going to be finding tangent of 55 degrees. I'm going to actually replace theta with the 55. Opposite is going to be straight across. So opposite of 55 degrees is x. So the opposite is x. Adjacent is right next to it, 10. So tangent 55 degrees equals x over 10. So let's use a calculator and let's figure out what's the tangent of 55 degrees. Alright, so we use our tan button. 55 degrees, 1.428 something something something. Okay, so I'm going to write that down. It's about 1.428 equals x over 10. We're solving for x. So the next step would be to multiply times 10 over here and do 10 times 1.428, which we kind of already know. I'm going to type in times 10, but we know it's going to be 14.28 approximately equals x. And we got our answer. Tangent's actually a really useful feature, and it gets more complex than this, but today we kind of want to just make sure you understand the concept of it's for 90-degree triangles, it's to help you solve for different legs, and it's this ratio, opposite over adjacent. So we're really focusing on that. So you're going to practice in class, and hopefully this helps, and we'll continue to work on it.